If you're interested in tracing carbon from live trees, crops, or grasses into the soil microbial community, an effective way to do so is using stable isotope labeling and probing. Now, stable isotopes are naturally occurring variations of common elements. Carbon, for instance, normally occurs as carbon-12, that's 98% of the time. Carbon-13, its isotope 1 neutron heavier, occurs 1 to 2% of the time. Now, we can use this to our advantage, as this carbon-13 moves through the ecosystem quite naturally with no difference from carbon-12. So if we were to inject plant carbon with carbon-13, we can trace the carbon-13 from the plant into the soil microbial community. Now, we can do that by either exposing the leaves to enriched carbon dioxide or by directly injecting carbon-13 sugars and organic acids into the phloem. We then measure the timing, the distance or location, and the size of the carbon-13 peaks in the soil, in the fauna, and in the microbial community. Now, a particularly effective way of doing this is using PLFAs, phospholipid fatty acids. To my left is a gas chromatographer isotope ratio mass spectrometer, a GC-IRMS. We use it to measure the carbon-13, carbon-12 ratio of our phospholipid fatty acids, our PLFAs. Now, we inject our PLFAs into the GC and separate it out by weight using this copper column. Then, we combust those individual fatty acids into carbon dioxide and concentrate them into a carbon dioxide beam. This beam is then injected into the IRMS. And using magnets, we separate this beam into carbon-12 dioxide and carbon-13 dioxide, at which point we can measure the ratio on our computer. Using our software, we've been able to identify each phospholipid fatty acid peak into two separate peaks, a carbon-13 dioxide peak in red and a carbon-12 dioxide peak in blue. This particular sample is very carbon-13 enriched, and it has a high carbon-13 dioxide peak. This indicates that the carbon enriched in the plant traveled through the plant into the roots, was exuded by the roots, and picked up by this particular phospholipid fatty acid, fungi, indicating that that fungi is very dependent on plant carbon. And this way we can see per mil differences in carbon-13 versus carbon-12. It is an effective way to measure carbon flow from trees into the microbial community down to the microbial group level.